hydrogen, the first element to ever exist, born from the fiery chaos of the Big Bang. It's not just an element, it's the cornerstone of everything. Hydrogen is the ultimate cosmic pioneer, making up 75% of all elemental matter in the universe. From the sun in our sky to the stars that light up the night, it's the fuel that powers celestial wonders. And what about here on Earth? Hydrogen is the lightest element, but don't let its simplicity fool you. This tiny atom packs a punch. But hydrogen's story doesn't end there. It promises a cleaner, greener future. Imagine a world powered by unlimited, renewable hydrogen energy. Cars, cities, even entire nations running on this sustainable fuel. From the dawn of the universe to the future of humanity, hydrogen isn't just an element. It's a story of potential, power, and promise. What's next for this extraordinary element? The answer lies in our hands. We often take elements like hydrogen for granted, but its journey from a mysterious observation to a fundamental building block of chemistry is a tale worth telling. It wasn't a single eureka moment, but rather a series of brilliant minds building upon each other's work over centuries. Our story begins way back in the 16th century with a rather enigmatic figure, Philippus Aureolus Theophrastus Bombastus von Hohenheim, or as he's better known, Paracelsus. This Swiss physician and alchemist was a bit of a revolutionary for his time. While experimenting with metals and acids, he noticed something peculiar. When he reacted iron filings with sulfuric acid, he observed the release of a flammable air. Now, Paracelsus didn't quite grasp the significance of this air. He didn't isolate it or identify it as a distinct element. But he did make the crucial first observation. Something new and flammable was being produced. Think of it as the very first spark in the eventual discovery of hydrogen. Fast forward a couple of centuries to the 18th century, and we meet the brilliant British scientist Henry Cavendish. In 1766, Cavendish meticulously repeated and expanded upon the earlier observations. He reacted various metals like zinc, iron, and tin with strong acids. But unlike Paracelsus, Cavendish went much further. He collected this flammable air and carefully studied its properties. Cavendish determined that this gas was different from ordinary air. He found it to be incredibly light and, most importantly, highly flammable. In fact, when ignited, it produced water. He even accurately determined its density. Cavendish called this gas inflammable air because of its key characteristic. Cavendish's work was a major leap forward. He had essentially isolated and identified hydrogen as a distinct substance with unique properties. However, at this point, he still didn't fully understand that it was an element in its own right. Enter the father of modern chemistry, the French nobleman and scientist Antoine Lavoisier. In the 1780s, Lavoisier repeated Cavendish's experiments. But Lavoisier was a master of systematic investigation and precise measurement. He conducted experiments where he carefully measured the masses of the reactants and products. Through these meticulous experiments, Lavoisier confirmed that when Cavendish's inflammable air reacted with oxygen, which Lavoisier himself had named, the only product was water. This led him to the groundbreaking conclusion that inflammable air was a fundamental element and a key component of water. And it was Lavoisier who, in 1783, gave this element its now familiar name, hydrogen. The name comes from the Greek words hydro, meaning water, and genes, meaning forming. So, literally, water forming. A perfectly fitting name considering its role in creating the very essence of life. So, to recap, the discovery of hydrogen wasn't a single event, but a gradual process. Paracelsus first observed the flammable gas in the 16th century. Henry Cavendish meticulously studied its properties and identified it as a distinct, inflammable air in the 18th century. Antoine Lavoisier finally recognized it as an element and gave it the name hydrogen, highlighting its role in forming water. Now that we know how hydrogen was discovered and named, let's take a look at how this incredibly light and flammable gas played a starring role in the early days of balloon aviation. From the moment Jacques Charles took to the skies in his hydrogen-filled marvel, hydrogen became the go-to gas for lifting humanity into the air. Imagine the excitement in Paris in December 1783. Just days after the Montgolfier's hot air balloon flight, Jacques Charles and Nicolas Louis Robert ascended in their hydrogen balloon. This was a completely different beast, sleek, efficient, and able to reach higher altitudes. These early hydrogen balloon flights weren't without their drama, though. Hydrogen, as we know, is highly flammable. There were numerous close calls and even accidents in the early days due to sparks or open flames near the balloons. It was a constant balancing act between the incredible lifting power of hydrogen and its inherent danger. As the 19th century rolled around, hydrogen balloons found a practical application in military reconnaissance. During the American Civil War, for example, both sides used hydrogen-filled balloons to observe enemy troop movements. Imagine being in a basket, suspended beneath a giant bag of highly flammable gas, looking down on the battlefield. It was a risky job, to say the least, with the added danger of enemy fire. Fast forward to the early 20th century, and we see the rise of the airship, particularly the magnificent Zeppelins. These giants of the sky relied heavily on hydrogen for their immense lifting capacity. Hydrogen was cheaper and lighter than the alternative, helium, which was difficult to obtain in large quantities, especially for Germany. The Zeppelins offered a luxurious, albeit slow, way to travel across continents. Passengers enjoyed comfortable cabins, dining rooms, and even promenade decks, all while suspended thousands of feet in the air by millions of cubic feet of hydrogen. It was a marvel of engineering and a symbol of progress, but the inherent danger of hydrogen was always lurking, and it was tragically brought to the forefront with the Hindenburg disaster in May 1937. As the massive airship approached its mooring mast in Lakehurst, New Jersey, it suddenly burst into flames. The exact cause of the ignition is still debated, but the presence of highly flammable hydrogen as the lifting gas undoubtedly contributed to the rapid and devastating fire. 36 people lost their lives in the inferno, a stark reminder of the explosive power we've been discussing. The Hindenburg disaster had a profound impact on the future of airship travel. Public confidence plummeted, and while helium was considered a safer alternative, its limited availability and cost made large-scale airship travel impractical. While smaller hydrogen balloons are still used for scientific purposes today, the era of large passenger airships filled with this flammable gas effectively came to an end. These anecdotes really highlight the double-edged sword of hydrogen in early aviation. Its incredible lightness allowed us to take to the skies in ways never before imagined, but its explosive nature always presented a significant risk. It's a fascinating chapter in the story of both hydrogen and our quest to fly. So, we've explored hydrogen's discovery here on Earth and its early uses in ballooning. But the story of hydrogen is far grander than our little blue planet. In fact, to truly understand hydrogen, we need to look to the stars. Hydrogen wasn't just discovered, it was born in the very first moments of the universe. According to the Big Bang Theory, in the incredibly hot and dense early universe, the only element that could form was, you guessed it, hydrogen. It's the fundamental building block from which everything else eventually came to be. And what makes hydrogen so fundamental? Well, let's take a look at its incredibly simple structure. At its most basic, a hydrogen atom consists of just one proton in its nucleus and one electron orbiting around it. That's it, the simplest atom in the entire universe. This simplicity is a big reason why hydrogen is the most abundant element in the entire universe, making up roughly 75% of the elemental mass of the universe. Hydrogen is even more abundant in terms of the number of atoms, accounting for about 90% of all atoms in the universe. Most of this hydrogen exists in the form of plasma within stars, as well as in interstellar gas clouds. It was the first element to form, and it's the primary ingredient in stars and gas clouds throughout the cosmos. However, the most abundant element in Earth's crust is oxygen, about 46% by mass, and iron, about 35%, in the whole Earth, including core and mantle. Now you might be thinking, if hydrogen is so abundant, why isn't it the most common element here on Earth? That's a great question. The answer lies in Earth's gravity and hydrogen's incredibly low mass. Being the lightest element, hydrogen gas molecules move very quickly. Early in Earth's history, our planet's gravity wasn't strong enough to hold on to these speedy hydrogen molecules, and they escaped into space. That's why we find most of Earth's hydrogen locked up in compounds like water and organic molecules. But out in the vastness of space, and especially within stars like our own sun, hydrogen is the star of the show, literally. Stars are powered by a process called nuclear fusion, and hydrogen is the primary fuel. Deep within the sun's core, under immense pressure and heat, hydrogen atoms are forced to smash together. This isn't just a simple collision. It's a process where 4 hydrogen nuclei, protons, fuse to form one helium nucleus. And here's the magic. A tiny bit of mass is converted into an enormous amount of energy in the process, following Einstein's famous equation, E equals mc squared. This controlled, sustained nuclear fusion is what makes the sun shine, and provides the energy that sustains life on Earth. Now, let's contrast this controlled nuclear fusion in stars with something far more destructive, the hydrogen bomb. While both rely on the power of hydrogen, the way the energy is released is drastically different. In a hydrogen bomb, also known as a thermonuclear weapon, a chain reaction of nuclear fusion is triggered in an uncontrolled and incredibly rapid manner. This results in a massive and devastating explosion, unleashing an unimaginable amount of energy in a fraction of a second. It's the same fundamental process that powers the sun, but without any form of regulation or control. It's truly mind-boggling to think about the sheer power contained within this tiny, seemingly simple element. From being the building block of the universe to fueling the stars, and unfortunately, being harnessed for immense destructive power, hydrogen's story is one of incredible might, despite its atomic smallness. It reminds us that even the most fundamental elements can hold the key to the universe's most powerful forces. So, from explosive discoveries on Earth to its explosive origins and power in the cosmos, hydrogen is a truly remarkable element. Now, after witnessing the incredible power of hydrogen in the stars, and even in destructive weapons, it might seem counterintuitive to think of it as a fuel for our everyday cars. But hydrogen holds immense promise as a clean and efficient energy source for the future of transportation. Let's dive into how this could work and address some of the key concerns. The idea behind hydrogen-fueled cars is using hydrogen in a fuel cell. This isn't like burning gasoline. Instead, hydrogen reacts with oxygen to produce electricity, which then powers the electric motor of the car. The only byproduct of this reaction is pure water, making it a zero-emission technology at the point of use. Now, one of the first things people think about when you mention hydrogen is its flammability. It's true hydrogen can be explosive under certain conditions. The explosion concentration range of hydrogen in air is quite wide, ranging from about 4% to 75% by volume. This means that even a relatively small amount of hydrogen mixed with air can ignite. However, the concentration of hydrogen within a hydrogen-fueled car is carefully managed and stored in robust, reinforced tanks designed to withstand significant impacts. Typically, the hydrogen is stored at very high pressure, but the system is designed to prevent leaks. Safety is the top priority in the development of hydrogen-fueled vehicles, and they are equipped with multiple layers of safety measures. It's also worth noting that while hydrogen is flammable, it's also incredibly light and disperses very rapidly in the air. Unlike gasoline vapors, which can pool on the ground, hydrogen will quickly rise and dissipate, potentially reducing the risk of a sustained fire in an open environment. While there are challenges to overcome in terms of production cost, infrastructure, and public perception, hydrogen holds significant potential as a clean and abundant fuel source for the future of transportation. As technology advances and we invest in more sustainable production methods, hydrogen-powered cars could play a crucial role in reducing our reliance on fossil fuels and combating climate change.
En descendant